Thank you for joining our 2025 webinar series, which is going to be speaking on climate and how it relates to soybean production today. A few things that I've got to, or I want to mention for some housekeeping, I guess, as far as the webinar goes. Some of you may have participated in some of our webinars in the past. It'll run very similarly. We'll have some beginning presentation with some information, and we're going to take questions and answers at the conclusion. But I would highly suggest everybody to be aware or know that we will be sharing information through the chat throughout the webinar today. So pay attention to that. There will be information dropped for your references. Like I mentioned at the end of kind of our presentation portion, we will go into a question and answer session where you'll be able to ask questions through the chat feature for the panelists and people that are participating in this webinar today. And the last thing that I wanted to mention is that we will be having some polls throughout the webinar. So you may see some things that pop up at various times. We ask you to please participate in some of these polls if you're able to. All of the responses with these polls will be anonymous, so your identity will be hidden. But just for the sake of interest in what the poll questions ask, I think it'd be really interesting if everybody would participate. So we're going to go ahead and get started. Laura, I'm not sure if you can advance.
I'm trying.
Okay.
Oh, whoa,
Oh,
it's very touchy. I'm trying too fast. I apologize.
okay. So, like I mentioned, everybody, today's webinar is going to be on climate challenges in soybean production. We have a list of presenters from across the United States joining us today. Dr. Chris Kucharik from the University of Wisconsin, Dr. Alex Lindsey, and Dr. Laura Lindsey, both from the Ohio State University. And then I'm Michael Plumblee from Clemson University, and I'll be participating in the webinar as well as moderating today's session. So, with that being said, I'm going to hand the reins over on the webinar to Dr. Chris Kuchart, who is going to lead us into some information on climate and how it relates to soybean.
Great. Thank you, Michael, and welcome everybody. So I'm going to start off by addressing some of the key challenges in farming that I think about often is that, we're now confronted with unprecedented changes in our weather variability, and oftentimes we like to look um, in the past for historical analogs that allow us to think about how growing conditions of the past may be able to help us think about the future. Unfortunately, we're entering this era of unprecedented types of weather variability where we're seeing things that there is no analog for in the past, and it's harder to use that type of information to think about how we might change and adapt in the future with our planning. So this figure here is just showing kind of a broad perspective, the annual average U.S. temperatures over the last about 130 years, and it summarizes that overall long-term warming trend. The total amount of warming during that time period is at about 1.5 to 2 degrees or so. But if we start to look more closely at sort of the 30-year averages. The climatology as we define it are 30-year chunks. And you can see that as these 30-year periods are compared to the overall long-term 20th century average, that the amount of warming is most prevalent typically past about the 1970s. And you can see the last two or three 30-year periods how that average has increased the most during this long-term time period. Um, if we look more closely at summertime, so just the June, July, and August averages, these two figures, the one on the left is showing the trend in the maximum or the daytime high temperature trends compared to the nighttime lows or the minimums on the right. And you can see quite a difference between these two. So on the right, the minimums, the nighttime lows, generally there's been, a far wider range and agreement of warming, across the whole US. And these are shown at the 95% confidence interval. So a lot of statistical significance and confidence that these are happening on just not just random chances. However, on the left, you'll see that it's kind of a tale of two sections of the country. On the left, west of the Rockies, the maximums generally trending, warmer. And then there's this sort of section of the central US where a lot of our soybean production is occurring, where there's actually been trends towards somewhat cooler temperatures with daytime highs. And it's often referred to as the warming hole in the central US. And this is often attributed to the increased productivity, increased planting density of our summer crops, particularly corn, in the long term, that have increased the amount of water vapor through evapotranspiration back to the atmosphere, which helps to keep us cooler. So you can see there's an effect there of the land management already and the regional climate. A concern that I have and other folks that study interactions between climate, weather, and agriculture is that trend is unlikely to continue in the shorter and the longer term. If we look at the precipitation trends, so again, each of these is showing a 30-year value compared and a difference to the 100-year average, the 20th century average. So it's much more speckled, a lot of more variability with precipitation. Some 30 years have been drier or wetter compared to the overall century average. But you can see again, in the last 30, 40 to 50 years, a sort of increase in precipitation across the whole country. And in particular, let's focus in a little bit more on just the last 30 years and change that percent change into an actual amount of inches. So again, east of the Rockies, in the last 30 years compared to the 20th century, we've been receiving about maybe 2 to as much as 5 or 6 more inches of rainfall on an annual average than we have been. In the West, it's maybe trended a bit drier, but definitely that's not the most interesting story on this figure here. And then if we just focus on summertime trends, so if you just look at the right-hand figure, which is the statistical more significant confidence in those results, you see that kind of a small area of the corn and soy belt through the I-states, Minnesota, Wisconsin, Michigan, is generally receiving upwards of 2 to 3 more inches each summer of rainfall than we had comparatively in the longer term. And there's a variety of reasons why we think that might be happening. Again, there might be some land atmosphere connections. It might be related to increased amount of water vapor through irrigation in the Great Plains. It might be migrating further east and contributing to increased rainfall. So it's a very interesting effect and something that obviously our farmers in the central U.S. have been dealing with, which is alluded to in this graph, which is the standardized precipitation evapotranspiration index. So that's a mouthful, obviously, but it's an index that's used to correspondingly tell us something about a drought versus extreme or excess moisture that's occurring. And this is done at the crop reporting district level. It's showing a long-term trend from 1900 to 2023. And it's again showing and sort of responsive to that increase in precipitation, where east of the Rockies we're trending towards more extreme moisture conditions more often than not, versus a trend towards more extreme drought in the west and the southwest U.S. Now, even though we're trending towards these wetter conditions, it doesn't mean that we're absent of experiencing drought. This figure here is taken from the U.S. Weekly Drought Monitor. It's a long-term trend from the year 2000 through 2023 that's just showing the percent of the U.S. land area that's experiencing drought at any given time, and also the different categories of drought. So it's not that we can't experience drought anymore. Of course we are, but it's just a matter of who's taking their turn geographically and regionally in any given year. One year it might be the Dakotas, and then another year it might be Illinois or maybe Wisconsin. whereas other areas might be experiencing more extreme wetness with their soils. And I think that alludes to the increased sort of erratic weather that we're experiencing and the higher amount of variability we see both temporally as well as spatially across the U.S. Other changes that we can take from the data that have been gathered. So the growing season length has increased dramatically, somewhere around 1 to 3 weeks greater typically today than we were back, 50 or 100 years ago. So that is changing, how we're, maybe either planting in the spring or the timing of maturity and harvest in the fall. I think most of the data suggests that a large percentage of this change is in the fall season, warming, later onset of that first killing frost or freezing temperatures that we experience. So the next part I want to talk about is the projections in changes in temperatures and precip. So these are taken from general circulation models that are used. Um, so the first figures, charts on the top there are looking by the year 2050, so the middle of this century, for two different scenarios related to greenhouse gas emissions. So a lower scenario and then one that's a bit higher and suggests that, we're ramping up and having a higher sustained increase in greenhouse gas emissions feeding back on the climate system. So uh, the punchline here is that, 2 to 6 degrees of Fahrenheit warming across basically all of the, central and continental US by 2050. And then by 2100, an even pronounced higher amount of warming, somewhere between 4 and 9 degrees. And this is for the annual averages. If we look at some estimates of what the projected impact on the growing season length would be in the Midwest US, so different, again, scenarios playing out through these climate models suggest maybe by 2050, maybe upwards of another 3 weeks of extension in the growing season. Then by the end of the century, maybe about a month to maybe a month and a half increase. So keep that in mind. Those are really significant increases over a very short time period in the historical record as compared to the historical record as we think about the future. On the precipitation side, so what's being shown here are the last 30 years of the 21st century compared to a 30-year period from the mid-70s to the early 2000s. Shades of green denote getting wetter. Shades of brown or light brown would suggest getting drier. The stippling, the red dots, suggests that there's statistical significance and agreement among the different general circulation models. So this is suggesting that winter and spring would be trending wetter in our regions by maybe 10 to 20%. During summer and fall, a little less agreement, a little more uncertainty, maybe trending a bit drier, maybe trending a bit wetter, depending on where you are in the US and also depending on which general circulation model you might be looking at. But one thing that, most of the models agree on is that frequency and extreme rainfall events, here it's about 3/4 of an inch or greater, that we've been seeing would continue to go up in the future. So adding another maybe 2 to 3 annual events of having those, 3/4 to maybe an inch of rainfall in a day happening as we move forward. So just to review a little bit about, the importance of temperature to our cropping system. So obviously, the impacts on photosynthesis and potentially where those temperatures fall in terms of the optimums for different crops and other species. Increased temperatures also increase nighttime respiration and loss of CO2. Impacts of temperature on the water use by plant and potentially driving increases in irrigation demands across the U.S. Increases in temperatures also influence the rate of the phenological development of plants and crops, as well as controlling the length of the growing season, as we've already seen, and also has impacts on the survival of pests and other diseases that challenge our growers and our management of those crops. So there's been a large number of studies that have been taken on in the last 15 to 20 years that are looking at things about changes in the weather and extreme heat and variability in weather and how that's controlling and exerting more control over productivity in our cropping systems. And it doesn't matter, generally what crop we're talking about. You can find stories that are related to any one of the important ones besides soybean. So I just wanted, and there's a lot on this figure, and I'm just going to point out the lower and talk about the lower right figure here, which applies to soybean. But it was one of the first studies that I read many years ago, published in 2003, that was showing, definitively that an overall trend in the growing season temperature was having an impact on the overall trend in yields. And this was done for both corn and soybean by David Lobel and Greg Asner at Stanford University. So in the lower right, it's just showing for each of the regions, or think of them as counties or subsets of counties, that places that were experiencing the highest rate of change in soybean yield were places where the growing season temperature trend from 1982 to 98 were cooling. So the cooling trends in temperature in the growing season were helping to produce the greatest gains in soybean yield during that time. And the reverse, places that were exhibiting a warming trend during the growing season had the overall yield trends lower than their counterparts in other sections of the US. And the overall response was that there was a 17% decline in yields for every degree of warming from those statistics. Since then, there have been other studies that have been done, including probably some of you that are on this call and maybe co-authored and were involved in this paper, that a combined effect of temperature changes as well as precipitation just over a 20-year period from 94 to 2013 suppressed the U.S. soy yield gain by about 30%. So again, we've seen these different time periods and different effects of these changes in weather having a documented, a pretty significant impact on yield gains for soy. So as we think about those changes in temperature over time, if we think simply just in terms of yield here on the y-axis versus temperature, there's some optimum range of temperatures that help maximize yield. And as the temperatures increase, as the variability from year to year keeps changing, you start to push and have temperatures that may push into warmer, outside of the optimum range, which would be accompanied by a decrease in yield. So not only would there be a decrease in the overall potentially mean yield, but also there's an increase in the overall interannual variability as farmers experience more wide swings. So in actuality, as the mean temperature goes above the optimum, you see a decrease in the mean yields and also an increase in the interannual variability. And so farmers end up experiencing an increase in the frequency of the bad years, unfortunately, because of this. We also know that, as I mentioned before, that the increase in warming, and let's say in particularly during winter, the overwintering of pests, and as they start to move further north into regions that have not already had experience with those, we see that the increase in crop losses to insect pests is related to an increase in warming temperatures, upwards of 10 to 25% per degree of warming at a global scale. So this is another challenge, just besides the effects of temperature controlling physiology and phenology, also, an increase in crop losses due to pests and also diseases. So how are, some examples of how farmers are adapting to changing weather? Here in the Midwest, we've seen an increase in more tile drainage, trying to combat that increase in more extreme wet conditions. And that exacerbates the other challenge that, we have in terms of driving the loss of nutrients more quickly from those fields. So unfortunately, it's helping solve, one problem potentially, but it's driving and exacerbating another problem with the nutrient loss. So I've got a couple slides here at the end just to summarize what I see as the impacts and challenges moving forward. So, increased risk of droughts and flooding, can contribute to decreased germination and crop loss, or increased use of groundwater potentially for irrigation during extreme heat or drought might be occurring more as we move into the future. Increased crop loss due to excessive precip, especially during seed germination periods, and that the increased frequency of those waterlogged soils can delay planting, or you might miss certain planting windows and harvesting. I think that's been one thing that's definitely been an increase since the 2010s and challenging farmers in the Midwest and Great Plains during springtime. Um, Increased frequency of extreme rainfall can also increase soil erosion, increase nutrient loss, and pathogen runoff to surface waters. And that also creates challenges in terms of manure management for those who have animal agriculture in our areas. So increased growing season temperatures can be pushing, outside of those optimum ranges for crops, might see increased heat stress to plants, susceptibility to insects and pests that we were just talking about, that may increase crop losses and may increase pesticide use and maybe have a reduced effectiveness because of those changes. Increased weed pressure, natural regeneration of exposed soils following rain, which would cause increased herbicide use and potentially water quality impacts. Increased growing degree days could be beneficial on the northern fringes where the growing season is shorter, but could promote a more rapid phenological development of our crops that push through certain stages more quickly than we're accustomed to. And then lastly, thinking about the extension of a fall and maybe an extended fall planting date and increased growing season for cover crops, that might increase, successive stand development. I'll just pick on corn just for a moment here, but a challenge that maybe some of those growers, might have is choosing whether to go with a longer season variety or to take advantage of a longer, growing season in fall and choose to get cover crops in the soil more quickly, so they have a chance to grow and produce biomass and so on and so forth. So, all right, that's what I have. I'm gonna hand it off to our next speaker. So, thank you.
Thanks, Chris. I appreciate the overview. I'm Laura Lindsey. I'm the soybean agronomist at Ohio State. And Alex Lindsey, he's my husband. He's also at Ohio State. And Michael and I are going to talk about some weather conditions, extreme weather and conditions we've seen in Ohio and other areas of the country over, I guess, the past year or so. So we're going to set this up as different scenarios. These are all real life scenarios that we encountered last year. So I'm going to set up these scenarios and then Haley will launch a poll question to see what you think would happen under these different scenarios. So we'll start with scenario 1. So this is Ohio last year. You're in an area of extreme drought. This picture is from the U.S. Drought Monitor on September 17th, so towards the end of the growing season. Ohio, pretty much the whole state was under some sort of drought condition. We had areas that were in a D4 drought, and it was the first time Ohio had ever been in a D4 drought since the U.S. Drought Monitor was started. So this is a very unusual situation for us in Ohio. We have dry years, but last year was extremely dry. So September 17th, things were extremely dry and soybeans were at 8% moisture, sometimes even less. I heard reports of less. We were starting to see pods being compromised. So you can see these pods are starting to split open because it's so extremely dry. And then a hurricane heads towards the coast of Florida. So this is Hurricane Helene that came in. That was right around September 22nd or so. So we call this a perfect storm of really having these really dry conditions followed by the potential of very heavy rainfall, specifically in the central and southern portion of Ohio. Some people got 4, 6, 8 inches of rain over the span of a weekend because of Hurricane Helene. So what kind of harvest losses can you expect? So Haley, if you can launch the poll for me. So I'll let you guys answer that question while I move on to the next slide. I won't give you the answer quite yet, but I see people answering. And I'll point out too, this is not necessarily unique for Ohio. The Science for Success team, I was able to reach out to various team members within the pathway of this hurricane to see, hey, what was the damage in your state? Other states that had really dry conditions followed by heavy rainfall had similar experiences. Some of that was in Kentucky, some in the Boot Hill of Missouri. I think Virginia had problems. Other states had less problems because their soybeans weren't as dry. So there were states where soybeans were earlier in that reproductive stages, so there was less damage. So this is what we saw after Hurricane Helene in Ohio. So this is pictures from West Central Ohio where the soybeans were extremely dry. This was not the D4 drought area, but it was a dry area in the state. And we saw severe losses after farmers harvested those dry soybeans that were then re-wetted and then dried down again. And one of the questions on the poll was, it will look like you planted soybean as a cover crop, and that's what it looked like. I see that's one of the top answers coming through. So it looked like a cover crop was planted. We had these really dry conditions, and when the soybeans were harvested, there was just a lot of shatter and a lot of beans on the ground. Another thing that we noticed was the soybeans turned black overnight. The pods turned black and the plants turned black overnight. So we had this rainfall come in over a weekend because of Hurricane Helene. I think Monday I went out to the field with our plant pathologist, and the color was just black in these fields. So some really undesirable characteristics there for the soybean. So I'm going to let Alex talk a little bit about what happened.
Yeah, appreciate it, Laura. Yeah, this was really kind of a challenging situation because a lot of farmers, sitting at 8% moisture, that's really dry for taking it in. So they were thinking if we get a little bit of rain, maybe it might re-wet the beans and help them gain some moisture points so they could potentially gain more marketability at the elevator. But in some ways, it kind of hurt our seasonality a little bit this year. The saprophytic fungi ended up causing that discoloration, as Laura had mentioned, and the dry conditions really had set those pods up for damage. And when we had those heavy rainfall events come through, it just made those pods split open. So we ended up losing more beans to the ground than were actually being able to be run through the combine in some cases. The other main issue that maybe we didn't anticipate was the damage to seed quality that we saw in Ohio this year as a result of this perfect storm of conditions. The seed coat during the dry down phase of our soybean production year was hurt by drought. Essentially, if seeds dry too quickly, they don't allow that natural contraction and setup of a solid seed coat for those seeds. And so that could lead to altered water uptake of those seeds and result in even premature sprouting of those seeds as they remain on the plants. So one thing to keep in mind is that potentially this year we may be looking at worse issues associated with germination and vigor of our seed lots, especially for the seed that's coming in for the 2025 season, as a result of some of these regionally specific extreme weather events that we experienced.
So what we learned this year, it's extremely important to harvest as you can when soybeans are dry. I know sometimes logistics make it so you can't harvest as timely as what you'd like, but sometimes I know farmers may wait because there's still leaves on the plants or maybe the stems are green. But really not delaying harvest, especially when those years are dry, is extremely important.
The other thing to consider this year is to really be vigilant to check the germination rates on your seed tags. Again, what will be reported is the standard worm germ test, and that's usually germination under the best case scenarios. In some cases, we may be seeing levels lower than we're used to seeing. Maybe we're traditionally seeing 90, 95% on our seed tags, but that could be down closer to 85, 80% depending on seed availability. So just be vigilant with checking that this year. If you're looking to position seed lots for early planting, consider ordering a seed vigor test to help discern which lots might be better positioned to perform well. A seed vigor test will artificially stress the seed lot before doing a germination test and can help correlate with better performance under more stressful field conditions. The last thing to consider might be treating with a seed fungicide if you haven't in the past, to help try to protect those seeds during that germination and emergence phase this year.
So these are some more pictures from the last growing season. It was interesting in Ohio, we did have drought conditions, but before we had those drought conditions, the northern part of the state was actually flooded. So we had extremely wet weather early on, then quickly pivoted into a drought, which I think was really harmful in the northern part of the state where it tended to be wetter and then drier. I think we had some poor root growth because of the saturated soils early on, and then pivoting to that dry period was harmful because we just didn't have very good root growth because of those wet conditions. And I know, Michael, wet weather is not something you're unfamiliar with in South Carolina. So you have some comments about what you saw last year?
Yeah, for sure. So, I mean, I feel like the past few years we've had a pretty active hurricane season, at least in the southeast. And whether it be a tropical storm or a hurricane, we've had some pretty excessive rainfall events that have caused some localized flooding. I know in 2024, between the tropical storm Debbie, Hurricane Helene, and one other rainfall event, in my particular area, we had about 30 inches of rainfall out of those three events, and kind of in between, we're still getting back to drought status. So it made it really challenging fall for us, just trying to figure out what to do. Some of the pictures that I've shared here were from last year, but also 2023, and maybe a picture or two from 2022. So kind of across years. The thing I think with the Southeast that probably helped us this year was with our low water holding capacity soils. Some of the earlier storms that we had probably actually helped us a little bit in terms of making some yield on some soybeans because we were so dry. But we plant such a wide range of maturity groups across a wide range of planting dates, with a lot of our planting dates being much later than probably the upper Midwest. So we were still a lot of green plants, still, early reproductive growth stages when a lot of the rainfall hit in 24. So we didn't have as big of an issue. Obviously, where we had water standing on the beans, submerged soybeans, we obviously had issues, but where we were able to infiltrate a lot of that water, it probably helped us in the short term, at least last year.
So, another factor, we have that wet side of things and then, quickly pivoted into that drought or heat stress. In Ohio, we started seeing soybean leaves flip over because of the drought conditions. And that was probably in July or so, we started to see those leaves flip over. Michael, you want to talk about some of the dry conditions maybe you guys experienced?
Yeah, for sure. So I think we went at least 30 days early season without any measurable amount of rainfall. The majority of our soybean acres in the southeast are not irrigated. So at least having enough moisture to get a good stand was definitely a challenge. We still are double cropping a fair amount of soybean acres behind small grain, but the dry conditions, obviously, when those soybeans needed to be planted, further impact getting a good stand, having some issues. You can see that in the bottom picture in the left. Um, but yeah, I mean, we've just seen, extended periods of drought. We'll see some pod abortion, flower abortion, things like that. And then you couple it with a big rainfall event. I know we had a field that we looked at this summer that it was an indeterminate soybean variety. It was irrigated, but it, obviously was going through a lot of drought and heat stress, supplemental irrigation really at best. And then we get a big 8-inch rainfall event and the soybeans wanted to kind of take off again. So we even aborted a lot of fruit just because of that, and probably ended up hurting our yield on that particular situation.
And then the end of the season in Ohio is, we had these sprouting soybeans. So again, with those really dry conditions, followed by the wet conditions with the hurricane, we saw an incredible amount of the pods split, and then those soybean seeds start germinating in the pod. So it looked like it happened in other states as well. Michael, was that something you guys observed last year, or was this in previous years?
So these pictures are actually from a previous year. A few years ago, we actually had two storm systems kind of meet over the state, and we had a lot of flooding, a lot of rainfall, really when the soybeans started to mature. And that's what some of these pictures are from. We still had quality issues last year with some sprouting and shrunken seed and just, you know, poor quality overall, low test weight from the rain. But we typically see, at least for us, a little bit of or more issue with quality when we're having our earlier planted maturity group soybeans, at least in the South.
Mhm. And I'll mention too, this is something the Science for Success team is actively working on. We have funding from United Soybean Board. Ironically, I called it sprouting soybeans, not knowing they were actually literally going to sprout last year, but they did. But this is an active area of research for the Science for Success team to look at various harvest dates and timings and how that interplays with soybean quality. And then seed quality issues too. We saw because of that dry and that wet, just a lot of shriveled seeds, just discoloration, and overall poor seed quality. And pictures as well from the south, showing those issues. Lodging. This is not something I noticed last year on our soybeans. Certainly with corn, we had a lot of corn fall over after Hurricane Helene. I didn't see as much lodging on the soybean side, but I think our soybeans might have been a little bit shorter because we were dry as well, wet then dry. But other states certainly had lodging issues because of the weather we experienced last year. All right, so looking at the poll results, it looks like most people put a moderate number of beans on the ground, and the other half of the audience said it looked like you planted a cover crop. So to me, it looked like we planted a cover crop, but there was a lot of variability around the state, whether it was a moderate or quite a bit on the ground. So we'll move into scenario number 2. So scenario number 2, we have some good days, occasionally in March, April, so maybe earlier than what we would normally plant. So let's say you decide to plant soybeans a little earlier than what you normally do in the north. However, after you plant and those soybeans had started to emerge, the temperatures dip down to freezing. Some of your plants die, and you're left with a very low plant population. Last year, in some of our trials, when we planted early, we went down to 42,000 plants per acre because of both wet and then coupled with freezing temperatures. So what kind of yield losses can you expect if you plant early? And I'll set up the scenario a little bit more. In our study, we planted March 25th, which is very early for Ohio. For that county, our early crop insurance date is about April 10th. So we're pushing it on that March 25th planting date. So what kind of yield losses can you expect? So I'll give you guys a minute to vote on that one. Having trouble controlling the screen. I think I'm drawing on the screen now instead of flipping. I don't know if Chris or someone else can see if they can figure that out. Or Haley. Can you click through Chris for me in case I'm oh wait, I got it. Maybe. I'm stuck.
So yeah, it's hard for me to control the screen with two of us because it's like competing. Um,
Yeah.
yeah. So let me
I'm giving you an extended time to vote now, guys. There we go. Thanks.
Yep.
Yeah, if you can flip through, that might be, I'm having a hard time controlling it. So what happened? So I mentioned we had an average plant population of 42,000 plants per acre. So those are outlined in red there. So you can see this is a drone flyover picture. And this was in July. So you would want a better canopy cover by July. But you can see in those red boxes, our soybean plant population was really low. It was 42,000 plants per acre, but it ended up yielding an average of 74 bushels per acre. So not as bad as what you would think. Certainly, I think that's a good yield. Looking at our other planting dates, we had April 16th, May 6th, May 24th. Those are not statistically different yielding. So those were all around the high 60s, low 70s. So same yields as that March 25th planting date, but our plant populations there were much higher, ranging to 125 to 138,000 plants per acre. And the stand was much more even. You'll kind of see some empty areas, some blocks in that field. Those are June planted soybeans. Those are planted on June 17th, so you can't see them quite from the drone. Those yielded 20 bushels less. So those were about 54 bushels per acre. So when we plant early, we oftentimes see those low plant populations, but soybean plants are fairly good at compensating for those low stands. So if you can hit the next slide.
Yep.
So why did that happen, Alex?
So I think what we were seeing this year with those stand reductions was the soybeans that were left potentially came about because of two reasons. Either number one, some of the meristematic tissue died, which affected how those plants ended up growing. If the top of the stem dies off, the axial meristems might take over and have some survival of those meristems, resulting in plants that essentially branch out instead of being a dominant stem with minimal branching showing up. Another thing that could have happened in those situations was a protracted emergence window for that really early planting may have resulted in survival of some late emerging seeds. So maybe we had a broader emergence window leading to some later emerging seeds actually surviving, but still being able to leverage that early planting date of March 25th. Even though they weren't emerged with the first round, the fact that they came up later, but earlier than some of our other planting dates may help explain some of that yield that we saw in that study you were describing. So next slide. So with that situation, if the plants are more spread out, they'll tend to branch more. They'll sense higher quality light, higher red to far red ratios, and result in more compact growth, but more branching. They'll end up producing more pods per plant as compared to plants that are at a higher density, and end up potentially producing more seeds per pod. And so that could help compensate for the lower stand because each plant is producing more seeds from a yield perspective. Also, because they had that earlier planting date, even if it was slightly later emerging, you still have more days with full sun before senescence gets triggered. Plant senescence in soybeans tends to be related to day length. And so if you have more days of seasonality before that senescence trigger happens, it's more days for photosynthesis to occur, more days to put on yield. And so we really may not end up seeing changes in maturation rates in those cases because you just have greater season length from that earlier planting date. Next slide. One of the biggest challenges with this sort of situation, though, is the stands may be very thin, and it could result in challenges, especially with canopy closure and weed control. So, Laura, you want to talk about the fact sheet here?
Yeah, this is a Science for Success fact sheet that many of us worked on, and it gives guidelines on how to assess your soybean stand. So it goes through steps on how to quantify your stand and whether or not you should replant, because that's can be a really challenging decision to make. And the fact sheet has guidelines from various states. You can check your state specific guidelines in that fact sheet. So next slide. One of the biggest issues when we see these really low plant populations is weeds. So in the case where we had those soybeans that were damaged by frost, what we saw was no damage to the weeds. So right next to my dead soybean plant, I had a happily growing giant ragweed with no damage. And so when we plant early, soybeans are really slow to grow. The plant population is lower, so weeds can become a really big problem. And we've done some preliminary research on some weed control programs, especially when you plant early. And what we've seen so far is you cannot rely on pre-emergence herbicides for season-long control. They can help, but they're not going to provide that control throughout the year. We saw that 2 post-emergence applications were needed, and that last one we included a residual herbicide, so that helped us with that season-long control. And one thing that was really surprising to me last year is how early our soybean plants flowered. So when we planted on March 25th, we saw flowering begin on May 28th. And so it was extremely early, and a lot of herbicides you may not be able to apply after flowering. So keeping an eye on flowering date is really important when you're planting early. So next slide. This is some of the freeze damage we've seen in Ohio over the past few years. The growing point is above the ground when those cotyledons are above the ground. So if you get those freezing temperatures, your soybean plants can die. Michael, is this something you see in the South? Or are you guys exempt from freeze damage down there?
I'd say traditionally, no, we don't see this. In the South, a lot of our soybean acres are being planted much after our last frost date for the spring. I will say though, we typically have what we call like an Easter cold snap. So around April 20th this year, we anticipate probably getting some cool weather. That typically is something that our corn growers deal with more so than soybean. Not to say it couldn't happen. I think our early coverage on crop insurance is April the 1st for planting date. So we could have the potential to have some soybeans impacted if we got into that early planting window here this year.
Thanks. Next slide. So we'll move on to our final scenario. This is scenario number 3. This is not from last year, it's from a few years ago, but still one of my favorite ones. So it's the middle of July and your soybeans are looking really good. Go ahead, yep. And then a storm rolls in and it starts hailing. You end up with 90% of your soybean plants defoliated. And you can see some, oh, you go to the next one, it's fine. You can see in these pictures here the extent of defoliation that we've seen. So 90% defoliated. So what kind of yield losses would you expect from that scenario? I think Haley has another poll for us. So it looks like with these pictures too, this is one, Michael, you guys are probably familiar with in the South as well. Do you want to talk a little bit about some hail damage experiences you guys have had?
Yeah, I mean, I guess it really just depends on the severity and how much hail damage we get. I've seen some hail damage early on that have, resulted in plants that have yielded just fine. It just kind of depends on how late, same thing goes. I mean, similarly to hail damage, wildlife damage, which we deal with a lot here in the South with deer. So it just kind of depends on the duration when it occurs. If we have enough growing season left to still produce a plant.
So Chris, you can hit the next slide and we'll see what the outcome was in Ohio. You can go to the next one. So Alex can summarize what happened here.
So what we saw was that with our maturity groups that were planted in the field, a lot of the damage related to yield related to maturity. So our early maturing groups ended up having about a 15 bushel per acre yield penalty from that hail event, whereas the later maturing varieties in that field ended up yielding about 7 bushels per acre less than the historical average. So some of the issues that we were seeing, next slide, please, are related to, again, that growth stage of susceptibility. When that hail comes through can really impact the damage. If it happens later in the grain filling stages, potentially the damage to pods could be greater, the damage to the leaf tissue that's feeding those pods and really contributing to the grain fill could be more detrimental as compared to a plant that might be earlier in its reproductive stages. There may be more time to recover, to compensate, to put out fresher leaves to help contribute there, and may result in a greater recovery time. And so, oftentimes with these hail and extreme acute events, the damage is really dependent on the crop stage in which it occurs. Next slide.
So for this, if you have hail damage, it's really hard to be patient. When we saw the damage in July, it was really ugly. But 3 weeks later, I went out to visit the field, and it was slowly starting to recover. It didn't really get taller, but they started, putting on new leaves, and looking better. So, be patient. You may want to contact your crop insurance person to evaluate losses. And one thing we did in the hail damage we had in Ohio was part of my variety trial program. So we did some side projects where we sprayed foliar fungicides at different times to see if that foliar fungicide would help the plants recover at all. And we didn't really see any effect there. So from our data, we're not seeing evidence of needing that foliar fungicide to help the plant recover after hail damage. So next slide. So we really appreciate your help or your attendance today, and all the speakers for this webinar. And I think we can open up to questions, Michael.
Yeah, for sure. So we'll move into the Q&A. We've got some time left before the conclusion of our webinar. We encourage y'all, if you do have questions, use the Q&A feature in the chat, and we'll either answer them through the chat if a lot come in, or verbally. And I know we've already got a few questions in, and I'll kind of moderate this and read them to the panel to get some answers and feedback on this. So just going ahead and jumping into this, we had a question come in: how does the U.S. soybean region climate changes compare with somebody like Brazil or South America? So I don't know if, Chris, you've got any, insight on kind of how we compare to South America?
Yeah. So I would say that, we have a larger region that's still not quite on the upper end of the temperature spectrum. Brazil's kind of already would be there. So they're more likely to be dealing with you know, things that are a bit different than us, where some of our temperature changes may in fact help some growers with a little bit of warming, at certain times of the year, extension of the growing season, things like that. So they're entirely two different regions. And I would say, Brazil's not, prepared, or, wouldn't be able to withstand any more degree of warming than given where they're at right now with their mean climate.
Okay. Sounds good. We've got another question that's come in. I think this is directed more at the Lindseys, but have you noticed a significant yield reduction in soybean due to temperature changes over the past several years, maybe the last 10 years or so, and specifically Ohio?
Yeah, that is one of Chris's papers that he showed, was looking at soybean yield trends over a certain time period. And I think one of the factors that rose to the surface of, in Ohio, of what is harming soybean yield, and it was high temperatures. I believe it was warm temperatures in July were negatively affecting soybean yield. And I don't know, Alex, if you have any additional observations on that one.
Yeah, I think we've seen yields continue to increase in Ohio over the last 10 years. Give or take, the trend has been for increasing yield. Some of what Laura mentioned is, I agree with the temperature in July does impact yield, and there's a negative association: higher temperatures, lower yield. But another point of interest is precipitation in August oftentimes is what people say makes or breaks yield in Ohio. And pretty consistently, if we get some rainfall events in the grain fill stages during August, yields tend to be a little bit better in the parts of the state that receive the yield than in fields where they didn't receive those rains. So I think there's a combination of both temperature and precipitation during the season that have been influencing our yield patterns throughout the state. But I don't know as if yields have been decreasing. I think we've seen generalized yield in state average increasing over time. Not a lot, but have seen that kind of been the trend in Ohio.
Sounds good. I guess another question may be directed at Laura. I know science for success is maybe not looked at this as a stress component, but as have y'all looked at anything in terms of stress reducing foliar sprays? You know,
Yeah, not necessarily to reduce stress. We've done a lot of foliar applications of insecticide or fungicides or other things in the absence of a problem. And usually, if there's no problem, we're not seeing any benefit to those foliar products. And I think there is a Science for Success fact sheet about soybean misconceptions. And one of the common misconceptions is if you have drought, you can spray something to alleviate drought stress. And I don't think there's a lot of evidence for those practices. I don't know, Michael, if you've looked at any of that in your state.
um, not specifically at stress. I feel like at least with us, a lot of times once we have such stress soybean or crop, we don't really get a lot of response from things, being applied or don't want to spend a lot more money on that. I know we've looked at several different things, wildlife feeding, trying to alleviate that sort of a thing. Tried to look at some maybe foliar products to see if we could boost any growth after something damage has happened and haven't seen a real big response from that, at least in our work. Another question, what types of diseases do you think could become major concerns in a high temperature scenario?
So I'm not a plant pathologist, and so I will give a scenario, but it's not the be all end all. But I know one concern we have in Ohio is frog eye leaf spot, and that's mostly associated with not having cold enough temperatures over winter. And so sometimes these pathogens can overwinter maybe more effectively because we're not getting as cold over winter. This year might be different. This year was extremely cold, but in other years it hasn't been cold. And I know frog eye leaf spot can be a concern. And one thing we've seen in Ohio when I first started about 10 years ago, frog eye leaf spot was more in that central or southern portion of the state. But about 2 years ago, we saw it in northern Ohio for about the first time in my lab. And so that's one particular disease we're keeping an eye on in Ohio because I do feel like it's moving further north.
Yeah, I would agree with that. The overwintering of disease and insects probably be a bigger issue for us as well. So if you'll notice on the screen, we've got two QR codes, one for an evaluation survey to get a little bit of feedback on how we can improve our program and what we're extending to y'all through some of these informative webinars. And if you're a CCA, make sure you scan the QR code to get your credits for attending this today. I just wanted to go ahead and mention that if you do not have the app to scan your CCA credits here, you can please send your full name and CCA number to an email address that's listed in the chat to Haley, and we'll make sure you get credit for those for attending today. Now, we've probably got time for a few more questions before we have to end with our session today, but what are soybean breeders doing to produce a crop that can withstand late season dryness or early season cold, wet conditions? Have y'all seen anything from a germplasm standpoint with your varieties that made them a little more hardy to some of the climate changes, I guess?
That's not something I'm too familiar with. I know our soybean breeders, wet is a big problem in Ohio, and so our soybean breeders have really focused on Phytophthora resistance. That was a big focus of our breeder at Ohio State. Beyond that, I'm not sure what's going on. Certainly, there's probably other efforts in other states for sure.
Yeah.
I think the good thing with that front is that all of these germplasm advancements and selections are happening under the climates that we're all experiencing, under the weather conditions and variable weather that we're experiencing. So there is some synergy in the selection process just because of natural variance in the weather. And so I think those are things that are continuing to happen. Germplasm is continuing to be advanced and breeding efforts are continuing to help us deal with these extreme weather variability events and just range in seasonality. Sometimes you're wet and then you're dry, or the opposite happens. You're dry and then you're wet. And so it's not just dealing with one type of stress necessarily, but it's being able to withstand a lot of different stresses at different points in time. And so I think that's kind of where a lot of the breeding effort is going to be spent moving forward, is looking at those, integrating new disease resistance traits into germplasm as well as we move forward.
Good deal. So I think I don't know who's controlling the slides. If you could maybe go to the next slide for me. I kind of want to wrap up to make sure that we are respectful of everybody's time. But if you enjoyed this webinar, we definitely highly encourage you to maybe join our next webinar that's coming up on March the 14th. It's going to highlight some economic insights for the uncertain times that we're obviously all dealing with right now and going throughout this growing season in 2025. So that's what's kind of on the horizon coming up in a few weeks, same time. So we would love to see you all there and attend our next webinar. You advance one more. So again, thank you all for attending today on behalf of Science for Success. Thank you to all of our speakers, panelists that have participated today. And if you have any questions or want to know more about what we do for Science for Success, we've got a new website. Follow us on Twitter. We have a very active YouTube channel as well.